Hi. Welcome to our class. Today we will discuss factoring difference of two squares. What you should be familiar with before this lesson. You should be familiar on how to identify perfect squares. For example, 1, 4, 9, x squared and y raised to 6 are perfect squares. A square number or perfect square is an integer that is the square of an integer. In other words, it is the product of some integer with itself. For example, 9 is a square number, since it can be written as 3 times 3. If a variable with an exponent has an even exponent, then it is a perfect square. To get the square root, we simply divide the exponent by 2. For example, y raised to 6 is a perfect square, its square root is y cubed. What you will learn in this lesson. In this lesson you will learn how to factor difference of two squares. Every polynomial that is a difference of squares can be factored by applying this formula. A squared minus b squared equals a plus b times a minus b. For a binomial to be a difference of two squares, two conditions must hold. First condition. There must be two terms that are both perfect squares. Examples are 25a squared and 16. Remember, an algebraic term is a perfect square when the numerical coefficient, the number in front of the variables, is a perfect square and the exponents of each of the variables are even numbers. Second condition. There must be a minus sign between the terms. 25a squared minus 16 is an example of difference of two squares. Since 25a squared minus 16 is an example of difference of two squares, we can now apply the formula to factor it. 25a squared can be written as 5a squared, and 16 can be written as 4 squared. In this example a equals 5a, and b equals 4. Therefore, the factored form of 25a squared minus 16, is 5a plus 4 times 5a minus 4. Next example. Factor, 100x squared minus y raised to 4. By inspection, we can see that both terms are perfect squares, and they are separated by the subtraction sign. Then we can say that they are a difference of two squares. 100x squared can written as 10x squared, and y raised to 4 can be written as y squared squared. In this example, a equals 10x, and b equals y squared. Using the formula, the factored form of the given polynomial is 10x plus y squared, times 10x minus y squared. You can check your answer by multiplying the factors. The product should be equal to the original polynomial. Next example. Factor w raised to 4 minus 81. The terms are separated by the subtraction sign, and they are all perfect squares. W raised to 4 can be written as w squared squared, and 81 is 9 squared. Using the pattern or formula, a equals w squared, and b equals 9. Then we can write w raised to 4 minus 81 as w squared plus 9, times w squared minus 9. The second factor w squared minus 9 is still factorable using difference of two squares. Using the pattern, its factored form is w plus 3 times w minus 3. Therefore, the complete factorization of the given polynomial is w squared plus 9 times w plus 3 times w minus 3. Last example. Factor 2x minus 50x cubed. Inspecting the terms of the binomial, we can identify a common factor. The GCF is 2x. Factoring it out will result to 2x times 1 minus 25x squared. 1 minus 25x squared is a difference of two squares. 1 is 1 squared. And 25x squared is 5x squared. Using the pattern, the complete factorization of 2x minus 50x cubed is 2x times 1 plus 5x times 1 minus 5x. I hope you learned something new today. Until next time. Goodbye and God bless.